Entity framework, our tool.
Netology suite.
Countdown commencing. T-minus 2 minutes.
Jeremy Likeness.
Shay Rojansky.
Chris Lanson.
Arthur Vickers.
.NET Data. T-minus 1 minute. Thirty seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff. We are go for .NET Data Community Standup.
Hi, we're back again with another .NET Data Access Community Standup, and we are very happy to be joined this week by Silvano Coriani, who is on the SQL Server team, an Azure SQL team at Microsoft, and he's going to talk to us a lot about what's new in SQL Server 2022 and how developers can be productive with that. So great to have you here, Silvano.
Thanks a lot, Arthur.
And before we get to that, we'll do a Toast is deciding to bark. We'll do a quick.
Excited about SQL Server.
Toast is really excited. She's normally a Postgres dog, but today it's all about SQL Server.
You don't have to be one or the other.
You don't have to be. No, we love you all. Okay, so let's do State of the Unicorn. And luckily, Shay is going to talk about this, so I can mute my mic. So we've got primitive collections support merged. Tell us about it, Shay. Briefly.
Right. Very briefly. So this is something we just merged for preview 4. So you're going to be seeing it in a few weeks when it's out. I think this is one of the major things where we're delivering in this preview. It's really nice. So what you see on your screen, this has been a longstanding problem in EF and Link. When you have like a parameter of IDs and you do a contains like this, like you're seeing on the screen, then what we used to do is we used to put the values of that array into your SQL. So we used to generate SQL that had the actual values inside, and that causes a lot of performance problems. I don't have time, so I'm not going to go into it, but you don't want to have different SQLs for each and every query just because the actual parameters and the actual array values are different, right? So what we did instead is we're leveraging the JSON support in SQL Server and also in certain other databases. What we do is we take that array now, that int array that you see above, and we pack it as a JSON array. So you see that the purple array there with 7, 27, and so on. So we encode that array as a JSON string. We send it as a string to SQL Server, and on the SQL Server side, we unpack it using this function you see below called OpenJSON, and that takes that array and makes it into basically like a table, like a result set on the SQL Server side, and then we can just query it as usual. So you see that this contains above the link thing gets translated to a where exists subquery, which runs which is much better because it doesn't cause planned cache pollution at the SQL Server side. It's generally like a much better way of doing things. But that's just the contains part of it. The really nice part as well is that what you can do now, because we've done all this work around JSON and querying JSON arrays and all that, you can also just have an int array on your entities directly. You can have a property of int arrays, and we will automatically map that for you to a JSON column in SQL Server. And that means you can now have an int array property on your entities and query it as usual. That means you can do stuff like, give me all the blocks where this property, this int array property contains the number 5, or has, on a column again, or has at least 3 elements, and the sum of those elements is above 10. So you can basically now have a collection of ints inside the JSON column very easily, and do the full range of link operators, and we'll just translate that for you, which I'm super excited about. I think this is a very cool thing. Exactly.
And we're going to, between the two of us, we're going to do the what's new for Preview 4. This we just managed to get this merged for Preview 4. There's still probably some polish that needs to go in, but the basics of it are merged in Preview 4. So we'll do a what's new on that, and then Shai's going to write the blog post about it as well. So we'll have more coming up about that in the next few weeks as we do that. Absolutely. Okay, and then one little last thing on here, not a big thing, but in terms of our AOT work, so Microsoft Data SQLite, so the ADO.NET provider price created for SQLite, can now be trimmed, done full trimming for AOT without any warnings or anything. So you can use that in your AOT applications, which is pretty cool. And I know Shay and his team on MPG SQL are getting close to having the same thing on MPG SQL, right?
Yeah, there's lots of work on that as well, and also making it as small as possible, trimming away what's not necessary. So yeah, that's actively being worked on.
Yep. All right, good stuff. So enough of that, and let's go and talk to Silvano. Silvano, what do you got for us today?
Great. Thanks again for inviting me. Actually, for the folks online, Arthur, Shay, and myself, over the last few months, have been working on a number of things in terms of collaboration between the SQL Server team and the .NET Data team. We hope this collaboration is and will kind of be more and more fruitful as we move forward.
Absolutely, yeah.
And so when they asked me to actually join this stand-up event, I just picked up a number of aspects that we have been recently working on for both SQL Server on-prem and for Azure SQL around kind of making developers' life easier when they create applications on top of SQL Server. I've been personally involved in a number of projects, internal projects, and activities that we are actually delivering through the 2022 version of SQL Server, and we've been working on over the last month. Some additional news you should expect probably next, actually in a few weeks, right? There is the Microsoft Build conference coming, and we will announce some additional new capabilities for the SQL Server family of products, I should say.
Excellent.
Right, and so for today, I just decided again to pick up a few of those topics. I actually collected them in a deck. Let me see if I can share.
Okay, so let's add that.
Okay, so it's a collection of topics that I actually assembled with a kind of agenda around few of what I think are the most interesting topics for developers. That starts from the very basic on how to set up SQL Server in a local development environment. The new SQL CMD, Go SQL CMD CLI that we created, which is, in my opinion, very exciting for developers that wants to spin up quickly kind of SQL Server environments locally, and potentially also create a continuum between kind of the local deployment and our cloud flavors of the SQL Server engine, right?
And that's cross-platform, right? As well, that you can
that is
on
cross-platform.
Yep.
All I'm doing today is on a Mac M1 machine. So this is just a testimony of pretty much all our tool set, which is moving into the cross-platform space.
Awesome stuff,
from VS Code extensions to our Azure Data Studio, and all the new capabilities that I'm gonna talk about later today, right? So some new also T-SQL enhancements. We keep kind of adding features and capabilities to T-SQL, including JSON. I saw Shay mentioned the JSON support.
Yep.
We are actually working a lot on that. So for now, you see the OpenJSON OpenJSON function plus a bunch of other functions that are available. Until now, we don't have a native JSON type, but stay tuned because again, over the next few weeks, you may hear more about that. And but our goal is to make JSON a kind of first-class citizen on SQL Server as well, right?
I think it's been really exciting as we've been working in this stuff over the last couple of years, integrating with EF Core to see the power that you get from a relational database and all the things it is good at, but also the ability to store documents in that database when you need the things that documents are good at, make more denormalized, bringing more bits of data together into one place. And it's almost like you've got polyglot persistence, but in a single database server, and we've seen this be successful. It's not just on SQL Server. I mean, Postgres, MySQL, SQLite, everyone does this now, and I think it's a really exciting path forward. So we're on our side. We're looking at leveraging that more and more. I've been working on stuff on JSON over the weekend. So good stuff there.
Yeah, and I think we've been all through this journey, like since some years ago, where at some point there was this kind of general belief that NoSQL databases were actually taking over the entire kind of data space. And they are actually great in doing certain kind of in covering certain use cases and requirements. But we also over time we also discovered that when it comes to certain intelligent kind of query processing capabilities, those relational engines that actually have been tuned and tweaked over the last 35, 40 years are actually very powerful, right? So
Absolutely,
and they can manage documents and objects actually pretty efficiently. So having the best of both and being able to combine kind of semi-structured and structured data together, it's becoming a very powerful addition to those engines.
Absolutely.
And I'm sure we will see more and more moving forward.
Yeah, it's worth mentioning, just so people don't get the wrong impression, SQL Server already has quite nice support for JSON natively. It has had it for quite a while. In fact, this is not even very, very new. So all the open JSON thing I just showed and we just talked about, it has been there since I think SQL Server 2017 or 16. I'm not even sure. Like that's already way back. There's an array. There's like a whole bunch of functions there. There's been new ones in 2022 that I've seen. So this is something that's already there, but from what I understand is about to get even better, basically.
Yeah, the bigger gap that we have right now is, we don't have a native JSON data type that the engine can actually, understand and manipulate and such. And the most important piece of this is indexing, right? Because today we are storing essentially JSON fragments as text, and although we do have, as you were saying, a lot of functions that can manipulate that text, can validate, can do extractions and such, those right now are not supported directly by native JSON indexes, right? And you can imagine that's an area that we are working on for for the very next future in order to add, to fill that last mile. And the good thing is that once you have that native kind of data type support, all the other capabilities,
Sure.
including what we will go through in terms of intelligent query processing, will naturally work on JSON data types, which is not really common on other environments where you may have that capability, but then it's rarely integrating
Disjoint.
with other
Yeah.
with other stuff. Like we on our end, from security to high availability, so replication, blah blah blah. These features are actually going to be fully integrated with the rest of the stack.
Very exciting stuff.
Absolutely.
Yeah. So maybe again, before going through this, I would actually like to spend literally a couple of minutes to recap, a little bit the journey that we had with SQL Server so far over the last 6 to 8 years, and what's new on SQL Server 2022, because maybe not all our audience is actually familiar with these topics, if you don't mind, right?
Absolutely, sounds good.
Okay, so let's start. I personally, I think SQL Server 2016 has been like one of those major releases after after some you may remember the R2 versus non-R2 dance that we had at the beginning of the last kind of decade, right? So we moved into from 2016 on, we moved into this kind of a regular or kind of regular cadence, and we introduced a bunch of capabilities. I think Query Store for 2016 is super important for both developers and DBAs the moment they need to look at the performance and the history of performance of a certain application running on SQL. But we added a bunch of other features like Polybase, so the ability to interact with external data stores in using different protocols and formats like object storage and so on. A lot of work around security with always encrypted, so the ability to use client level kind of encryption key for basically end-to-end security and the ability to basically manage from application perspective encryption, so that even DBAs cannot actually look into encrypted data there, right? And
that's been super popular.
And that's probably one of the differentiating ones. I know other databases don't typically have such an integrating end-to-end story around encryption. You have to cobble together certain things, and you don't get it necessarily end-to-end. So it's quite a thing.
Yeah, and in 2016, we also extended all these features, pretty much all the features that SQL Server Engine always had, to the standard edition as well. So that was a big kind of a change from a licensing perspective, so that people can run actually SQL Server Standard, which is significantly cheaper than the enterprise versions. On applications and deployments that may not be as may not have the highest budgets that maybe enterprise companies have, but we are and from 2016 we actually extended year after year this kind of opening up the previously called enterprise capabilities to pretty much every single SQL Server instance, right? And in 2017, that was a very special release, because for the very first time we introduced SQL on Linux, right? And containers. This is basically what I'm using.
That's massive.
On a daily basis.
Same here.
I have to say that I was skeptical when I was like, okay, SQL Server on Linux. Okay, let's see.
Nobody
if this is good.
believed this.
And I was like, wow, this really works. This is good. This is like it's easy to install. Even I could just get it up and running. It's like, wow, this is this feels good. And it's not super slow. It's the perf works on it and everything, and yeah, it's game changing.
And this is in my opinion, this forms the basis for a number of new improvements that we keep adding, and even the journey between the Windows version and the Linux version. There are research papers out there that if you search on the internet, you will find them, and a couple of very deep sessions that our engineers created back in those days that are documenting how we did it in a relatively short amount of time, thanks to the kind of the approach that was introduced. But in addition to the Linux support, we kept kind of adding new capabilities at the query processing level, which is becoming one of the kind of focus areas that the team is investing more, together with enabling kind of new scenarios, like, for example, graph support. So if you have workloads that require, in addition to kind of traditional relational capabilities, also graph semantic, in order to find, for example, proximity between nodes and stuff like that. We actually added these capabilities in 2017, and we keep improving release after release. And this goes to the polyglot aspect that you are to mention, right? So there is
there's an issue on the EF Core GitHub repo about adding support to EF Core for SQL Server graph databases. So if that's something you're interested in, go vote for that issue. I think it's got a fair number of votes already. We certainly hear about it through several channels. It's quite a big undertaking, so it's not something we can do lightly just take on with 4 developers on the team, but vote for it, because I think as Silvano is saying, that again, it increases your capabilities of dealing with different types of data, different types of queries, all of that polyglot stuff.
Yeah, absolutely. And between again, the graph semantic that we are adding at the engine level, and we will see some of the additions that we are making at the API level for interacting with the database engine in a different way compared to let's say the more traditional use cases and scenarios. We think this kind of polyglot aspect is extending and improving more and more. And we know that modern kind of application development scenarios are all about kind of integrating different languages and different kind of API formats and such, right?
Okay, so the question on everybody's mind: when are you integrating ChatGPT into SQL Server? I'm just kidding.
No, you should not.
I should not kid.
Yeah, because actually, there's more on that. And again, at the Microsoft Build, we will show something that has something to do with data and ChatGPT. So
okay,
looking forward to seeing that.
Yeah, I think this is an interesting news that
I knew I should have copyrighted this idea.
Yeah. And the although we will probably start introducing this in the analytical space, you should kind of let's say envision also this for the operational databases, because there are a number of interesting scenarios, like you can imagine, like designing a schema for a database, right? With some kind of support by some kind of intelligent copilots or something like that, right?
I can definitely see something like this for sure. Absolutely, yeah, makes a lot of sense.
Okay, so over as I was saying, over the last few years, we improved some areas, and then SQL Server 2022 came, and these are the key areas that we've been investing on. Every release now, we are focusing on a number of key areas. The cloud connected aspects, of course. Ideally, we would like every single SQL Server engine to be cloud connected, to be able to enable some scenarios from a high availability perspective, from an analytical perspective, per view, for example, from a compliance and security perspective, the ability to, for example, you may have like hundreds of SQL instances and the ability to manage compliance across all of them through this kind of cloud-connected capabilities that we are making into the system. So this entire cloud-connected thing is a very important one. But my favorite actually is the kind of query intelligence that we are making, that we are building into the engine itself, what we call intelligent query processing, where we are adding more and more capabilities to actually self-tune, also on those scenarios where maybe the developer or the creator of the database was like not necessarily using all the best practices, let me put it that way. So the ability from the engine to actually come out with always the best query plan possible, right? Despite the fact that there may be like data skews or cardinality issues in your data, and the engine is actually adapting, even if there's no perfect index or no perfect updated stat for that particular predicate that the developer is using, right? So that's an area that we will continue to invest a lot moving forward, because we think that is one of the key differentiator for the SQL Server engine, right? Data virtualization, it's again another area that we keep investing. So the ability from the SQL engine to connect to external stores can be other relational stores like Oracle or whatever, or object storage like Azure storage or S3 in AWS and so on, and also to use some of the new formats like Parquet, the Delta format and so on. So that's an area where we see that the intelligent capabilities, the query intelligence capability, can actually reach out to other storage engines and still be efficient in data integration scenarios, right?
Yeah, that's another thing that I've not necessarily seen in a lot of other databases. That's a very interesting point. I know also, for example, at some point I was very interested in columnar data stores, which SQL Server has an option for. So when you don't want to represent your data as rows, laid out as rows on disk, when you want to lay out the data as vectors, because operations can be far more efficient when the data is laid out in vector style and so on. So the fact that SQL Server can natively support these things at the data store level can be very strong. That's true. Yes,
and not only that. So yes, SQL Server can support columnar data store for those kind of scenarios like aggregations and more like the analytical type of queries that you run locally. So we have this highly optimized index type that we run, but basically in some cases can really replace your traditional row store if you create, for example, a clustered column store on your existing table, or can be dedicated to those analytical queries, but still it's running on your local database. With data virtualization, what we can do is actually we can connect to, for example, Amazon S3 bucket where you have Parquet files, and those Parquet files are actually columnar organized, right? Because that's the format that Parquet is.
You're exposing foreign data that's outside the database as if it were native SQL, basically tables, right? This is the kind of thing.
Yeah. That is correct. And although, of course, there will be the latency aspect there, because it's an external call. If we consider those analytical queries, latency is much less important, right? An analytical query compared to a highly transactional OLTP. So actually, performance are very, very interesting, and we have some demos where we are querying literally hundreds of billions of data of rows in external storage with decent performance, in the range of seconds, right? Which is pretty impressive.
Very
impressive, yeah.
I'm a little bit familiar with the analogous, like the similar thing on Postgres. They have a thing called foreign data wrappers, FDW. That would be like the similar thing, but obviously, the devil is always in the details, and what is actually possible is the interesting part. So that's part I actually didn't know about. That's very cool.
And last but not least, as I was saying, we keep extending the T-SQL programming surface So we are adding features that are making developers' lives easier. The way they are actually writing the SQL code, SQL queries is becoming easier because a lot of maybe complex logic is going to get encapsulated in native T-SQL functions like greatest, or which is giving you back the greatest value across a series, or for example, for example, a lot of time series helpers, like for example, date bucket, right?
Mm-hmm.
It's typically in let's take an IoT scenario, right, where you have timestamp based data that are generated from machines and sensors and so on. You typically want to analyze trends over certain time periods and so on. Now with date bucket feature, we can actually do a group by on a let's say 5 minutes bucket with a very simple syntax. You could have done that even before, but writing like a 20 lines long kind of SQL query, right, which was making things more complex and so on. And now we are encapsulating a lot of these capabilities in very, very easy to use functions.
Very interesting.
I think this is one of the areas where hopefully the closer collaboration that we have between the two teams is helping, because Shay does a lot of the query. Shay and Mauricio they're figuring out how to write queries against the database to do various things, and then we can kind of provide feedback. Like, if we just had this tweak to T-SQL, or we could do this additional thing, it would make those queries so much easier to write, so much simpler, and potentially, much more performant as well. So yeah, I think things are really getting better in that area.
That brings one very small point to mind. As part of these additions that I was just working on with OpenJSON, we now for the first time introduce into EF Core a mechanism where we can vary support based on the SQL Server version that's being targeted, so that we can take advantage of new stuff. So functions like greatest, this is like a small thing, but it's greatest and least are two functions introduced in T-SQL introduced in 2022, right? Which map very well to .NET Max and Min, and so we should be translating these, and we've traditionally not really done that because there's not been a way to vary support based on which SQL Server version is actually being used. So that's also a thing that we've just done in order to unlock the possibility to take advantage, to expose like these new querying features to users who use them, who want to use them. Anyway,
Okay, so is my screen readable?
Yeah,
absolutely.
Good.
Absolutely.
Okay, so I think it's enough kind of talking over slides. I just wanted to show you something live, and I would start from the new SQL CFD, because we think that so a little bit of history. I think it's 25 years ago when we introduced the SQL CMD .exe, which was a Windows-based executable to connect to a SQL Server instance and to run queries over command line, right? And that was actually
even Windows at that point, or was it MS-DOS at that point?
No, I think it was Windows. I'm
Windows,
talking about 96-ish, and that was actually replacing an older tool called iSQL that was coming from the old days of Unix and the original SQL Server from Sybase, but nevertheless, so we thought it was about time to actually modernize a little bit the command line experience for SQL. So we actually created this version using Go, so Golang, and the reason is it's much easier to get everything packed in a small executable, and to kind of eliminate dependencies and make it portable across different platform. So we actually
something that the .NET team is working on pretty hard, though, to narrow the gap there and make it possible to do this stuff with .NET as well. But Go is really good at it. And
we also made this SQL CMD CLI available in all the package management flavors. So you can find it here on Mac with Brew. You can find it on in the various APM package management on Linux. So you can find it, of course, in like Winget on Windows. And I already have installed. But with literally one click, you will get all you need to start working with SQL Server in a completely different fashion, right? So this modern SQL CMD is built with the same kind of approach that some of the CLI tools, like I don't know if you're familiar with like kubectl, kube control for Kubernetes, right? So it's
yes.
Basically you have this concept of context, right? The context is essentially representing one environment that you are working on. And on your machine, you can have many contexts, many users, and such, right? So in SQL CMD, right now, when you, this is not exactly what I wanted to do, sorry. You can actually create define your configurations, install your SQL Server, even Azure SQL local emulator. You can install tools, and then basically manage all your SQL Server environments from a SQL CLI tool. Just as an example, I can do SQL CMD create. I have it in memory already. So I can create a brand new environment on my machine called MS SQL. I need to accept the EULA. And then I can, for example, point it to an existing backup file, right? Which is available somewhere, reachable from my machine.
Very
and
nice.
when I'm doing this, what it's doing is downloading the latest, because I can give him a specific tag for downloading a certain image version, right?
So this is setting up the container, a Docker container, even with on your machine. With,
any kind of container management service that you may have, like Podman, Docker, and so on. And once it's done, it's basically again creating my local container, is setting it up, and is also downloading this backup file, is basically importing into the container and is restoring the database. So that right now I'm in the environment and I can run something like a SQL CMD query, and I can select, for example, the current version that I have installed. This is the very latest bits, the CU3 for 2022. So I can create my query. I can open my tools, for example, and I can connect from my, for example, this is Azure Data Studio. I can connect to that instance, and I can start creating the queries against that database. But as I was saying, I can have multiple environments. Like in fact, when I do SQL CMD config view, I can see all my different environments here. Right now, I have actually a couple of different environments. So this is the YAML representation of all the environments that I have on my machine. Right now, I have couple of endpoints that I can connect to, and I can actually switch context. Right? I can do SQL CMD config, and I actually need to remember what the command is. Is config use context, and my other local DB3 was the other environment. And for example, I'm now switching to a completely different environment. And if I'm querying my database, you can see that this is a different version, right? Okay. So I can have like 10 different releases because I'm testing, for example, my app against different versions of SQL Server. I may have a 2017, a 2019, and I want to test my code against
very impressive.
I think I'm going to go away and use this like right after this, because I have a database that I have that I need to debug, and it's on a version of SQL Server that I don't have, and I put it off, for a couple of weeks now, that task, because I was like, oh, I've got to install a different version of SQL Server, and I don't want to do that because it's going to be a pain. But if I could do this, I could just like get it, and I've got the back file ready to go. So just run it.
The big thing for me, so whenever I need, for example, to even if I don't need another version of SQL Server, I just have my one version. But for example, even just restoring from a back file, that's something that typically, I would have to switch to Windows. I work on Linux all day long. I switch to Windows to have SSMS so that I can do the UI thing just in order to do the back. That's horrible. I hate it. So this is really exciting to me.
Completely agree. And when you're done, you just say delete, right? And it will basically remove the entire thing, right? So what I'm doing right now, for example, I have my production quote unquote instance environment that I keep, and then if I need to do like a quick test on a different version and so on, I'm just deploying a brand new, and I can run my code. I can point to an existing database backup, and it's ready for going.
Very nice. I'm personally very excited by this. I don't know about I don't care what others say. I'm definitely going to.
There's a lot of comments in the chat saying this is really exciting. We do have one question here. I'm just going to bring up really quickly because we always talk about the latest things, but we know people are on old versions. So can you do this with older versions?
You can do back, as long as it is supporting containers, right? So we can do that with 2017, 2019, right. And because again, this is based on Docker containers running on Linux. For Windows containers, it's a little bit more complex, but we are looking into that. But there are no kind of short-term investments.
So update, if you're still on 2008, you definitely need to be updating. Stop watching this and go update your database.
I think we stopped supporting 2012, literally last summer. So you should probably move to. And by the way, all this it's for development and test. You don't need any license. It's kind of all free, quote unquote. So ramping up and learning about SQL and writing your apps against that is basically at no cost.
So I don't know if you're going to cover this later, but I was intrigued to see, and it's something I don't know very much about yet, the Azure SQL emulator.
Yes.
And so traditionally it's always on Windows you could use local DB for testing, which kind of works well in a lot of cases. It's not necessarily the best in every case, or you do what I think a lot of on EF we do, which is install developer edition on our machine. But should we now be using the Azure emulator?
Yeah. So I'm gonna cover it right now. So Azure emulator for us is the way we see it is part of what we call local development experience for Azure SQL, right? Which means that we have a bunch of use cases and dedicated scenarios that we are enabling, and the goal is, of course, to give developers the most high fidelity local image of Azure SQL database possible, so that they can start developing their app with confidence on a completely kind of disconnected scenario, and then they can push the database in the cloud whenever it's ready, either directly or through a CI/CD pipeline using things like Azure DevOps or GitHub Actions, for example, right? Of course, it's impossible, and we will never be able to bring the entire Azure SQL infrastructure on your local machine, right? It's way too complex. It's been designed to run on large clusters of cloud machines, right? But what we can do is actually to have again a container which is actually based on a Docker image or a container image, which is again as close as possible to the syntax, to the surface, the programming surface of Azure SQL database, right? And for us, this experience actually starts with this idea of a database project, right? So in Azure Data Studio or in VS Code, we have extensions, the database project extension that lets you to create the model of your database. I have a very simple database project here based on Adventure Work LT, and so this is just based on a bunch of tables, customer address, product, blah blah blah. And what we can do locally here to start that kind of validation cycle, we can change our target platform and say our target platform is actually Azure SQL database. Okay, and once you select your target platform, all the build and the kind of validation system locally, completely offline, will make sure that your project here is consistent with Azure SQL database cool. in terms of kind of, let's say, design time, right? And we can publish, we can build our project here, right? And if the build system here is telling us that there are 0 errors, we are good to go, right? And then we can start testing our little database project and say, okay, I'm going to publish this, and I'm going to publish this to the new Azure SQL Server local development container, right? And here we can just pick up an available port. I'm going to pick up 1435 because that one is for sure is taken, and I need to select a very secure password here, and then I can pick up the Docker image that represents my Azure SQL database emulator, right? Cool. We are planning to have an extended set of images here because if you think about that, in Azure SQL, we are actually releasing many, we have many deployment trains going, right? Mm-hmm. And this is the promise of the PaaS model, right? So we are actually, constantly upgrading our release. And what we are planning to do here is to have the ability for developers to pick up a specific version, right? Mm. Can be the latest or can be one precise, and make sure that they can test, for example, their apps, even on our future builds, right? The builds that maybe will be deployed in production in a week from now, right? So that's an area that we are working on to make sure that developers can test their applications with confidence on our latest builds running in the cloud. Right? So if I'm accepting this and I'm publishing, what my extension here is doing is it is downloading the image if it's not already available. It's creating a container and then it's publishing my project in the local container, right? So I can start actually, is using, of course, the DACPAC format for this, and is publishing on my kind of localhost instance the project that I was working on, right? And this is successful, so now I can actually connect to this one, and we should see, here it is. Okay, so we see our kind of database is there, is up and running, and I can start working with this. I can start querying and do whatever application development against this. And once, cool. Of course, once this is ready, and I run my test and so on, I can actually publish this to my existing or my new Azure SQL Server in the cloud, right? And this is the manual. Is the manual approach. But if this database project is in a Git repo here locally, I could push this into my GitHub repo, and from there I can kick off, for example, a specific GitHub action build to publish my database into my production environment or in my test environment, right? And so on, right?
So even
Right.
though you're doing all of this right now through Azure Data Studio using the UI, this can all be done with the command line as well.
Correct.
Right.
The idea is to everything which is available here through the through the Azure Data Studio and VS Code is available also through the command line.
Excellent. Yeah.
So this is the story that we have around kind of deployment of new SQL Server releases and also making sure that that developers can actually start be productive as soon as possible. Let's say.
Okay. Very cool.
Okay, so let's move to the SQL. T-SQL enhancements. As we were saying, a bunch of new features that we are adding. From a JSON perspective, we added a bunch of new functions here. The name is pretty self-explanatory. So it's JSON is basically taking a string, a JSON fragment, and is checking if it's a valid JSON. JSON path exists is checking if within that object or that column that we are passing that a particular path actually exists, right? There are a number of scenarios where before, for example, converting a fragment into a tabular structure, you want to know that a particular branch in your document exists or not. We can generate with JSON objects, we can generate pieces of a JSON fragment, so we can actually compose JSON documents in a much more flexible way, right? Through the JSON object function. Now we can. In the past, you had to use a complex kind of for JSON plus a bunch of kind of complex schema references. Here, this is making composing deliberate fragments much easier. And same for array, we can pass a set of data from the relational world and create a JSON array out of that. That may be again part of a bigger object and such. Right.
Nice.
And this list again, you should expect to be populated very soon. In the other T-SQL areas, as I was saying, greatest and least, again, string split, all pretty self-explanatory and very intuitive to use. In the string split, you pass a string, you pass, what is the delimiter, and it will give you back essentially a set structure out of those, fractions in your string. The trim function has been added. There's been like the left and right trim capabilities that have been added to the trim function, which was existing even in previous versions. Date trunk in order to again get a portion of your date time structure. Like for example, you want to only have the day part or the hour part and so on. So manipulating essentially dates, especially for again where you are using this in a predicate or in a group by. Those are very handy. And the window close. So window functions are pretty powerful. Pretty powerful capability that relational engines, not just SQL, has. So the ability to basically treat your detailed data plus aggregations with different
in a window
level, windows of aggregations within the same kind of result set is a pretty powerful close. And now we are making this a lot simpler from a syntax perspective. I will show you a quick demo later on. And a bunch of also kind of bit and kind of shift operation, bitwise operation, I would say. Because believe it or not, there are a number of use cases where actually manipulating bits, packing bits, shifting and such is common. Right? Yeah. So in order to make your data access even more kind of efficient, right?
So we
And
need to have translations for this stuff in AF Core, right, Shay?
Exactly. That's what I was about to say. Yes.
If
we need that.
some of, I mean, the window functions is been on a backlog
Different.
for a while. It's quite complicated, but some of these are probably, so if you're watching and you want to do a PR, then something like Greatest is probably a reasonable choice, wouldn't you say, Shay, to do as a community contribution?
Absolutely. Usually, like, translations is one of the easier things to do, and also very satisfying. I personally love adding translations. It's just a huge fun to suddenly, get your link to translate to this new thing. So, but by the way, I noticed, Silvano, you jumped over the distinct from, which I'm personally very, very interested in. But maybe I don't want to take up too much time. Well,
no, distinct from that is very, very helpful. Especially in scenarios like, for example, like index-based, like, for example, index-based access to null values. That is, so sometimes when you are, for example, looking for distinct values across a data set and you have a column with multiple null values in it, right? You can either use like brute force and do a scan of that table. Otherwise, it's or you, for example, again, if some of those values are null and you are just using the isNull typical function, you will get 0 results back, right? So this is not distinct. In this distinct, we give you the ability to actually, for example, get a very precise result using actually an index. Even if you have kind of null values in that particular column.
I'll definitely be looking into this. Like, one of our big problems in EF is bridging the behavior discrepancy between a language like C#, how it treats nulls, and SQL treats nulls, which is a completely different thing. And this thing, I know Postgres also has a similar thing, but that's actually not very good with indexing, which is why we've not gone into it. So that's, anyway, we have to do a lot of tricks in EF to compensate for this difference.
This is Maurice's like area of expertise, like dealing with three-valued logic versus two-valued logic and all the null semantic stuff.
And a lot of these functions are actually making life much easier and making certain patterns a lot simpler to implement, actually, right? And last column here, from a time series perspective, the date bucket function that I was mentioning previously to kind of bucketize kind of events on a time scale. Generate series, again, the name is pretty self-explanatory here, like first value, last value on a sequence, and so on. And again, this is another time series. If you may remember, in the past we had this functions available on Azure SQL Edge, which was a dedicated release of the SQL engine for specifically for IoT scenarios. Now we are extending this to the general usage across all the different flavors, from on-prem to cloud and so on.
Yeah, we got a comment earlier that just showing now about time series being something that they really appreciated. So great to see improvements on that.
Yeah, I don't know. We are out of time. But by the way, there's if you search for SQL 2022 workshop over the internet, especially on GitHub, we have created a fully packaged a set of kind of demos and scenarios that you can reuse and test your own. Those are perfect in conjunction with this SQL CMD easy way to install SQL, and you can run across all of the demos and the topics that we are talking about right now. So for example, if we pick up let's pick up this date bucket, for example, right? So there are few examples here on how you can use the date bucket function, which takes typical three parameters. One is the date part that you want to bucketize, the number of elements that you want to bucketize, and the start date. And for example, let me give you a quick example here. So I have, for example, a number of orders, right, in my sales orders table here. And I want to bucketize, I want to group them on a weekly basis. And I want to start from the first day of the week, right, and calculate and do a count, basically a group account that starts from the first day of the week of my table, which has a order date column here, which is a date time, right? But we don't know exactly that date time, which day of the week actually is, right? So I can use my date bucket function here, and I'm going to use the week, and I want the first kind of day of the week, and then I'm basically doing a cross apply between the original table and the day which is represents the first day of the week, and then I can group by using that first day of the week as date, right? So if I'm running this, I need to pick up the right database, which is this guy here. Oh, I think I'm connected to the wrong one. Here we are. Now I have too many
live demos.
Yeah, which is this guy here. Oop. Here we go. And so you can see that. And for example, 31st of December 2012. That's the first day of the week. If I'm actually querying that table myself, you will see that, and let's make sure we are picking up the right one. Worldwide importers here, and I'm taking this orders. Okay, so you see the order date actually starts from the 1st of January 2013, but that was not the first day of the week, right?
Very cool. Yeah.
So
you're projecting from the actual order date to the first day of the week for that order date.
Exactly.
Yeah.
And I'm grouping, for example, the 6th the 7th of January is into the new week and not the old week, even if it's just 7 days after the the first date that we see here, right? So this is an interesting. So we can bucketize dates and times on a whatever is the level of granularity to do kind of very powerful kind of grouping and aggregating functions, and we do that in a very powerful way. So behind the scenes. So this is doing a scan because I don't have a where closed here, of course. So I'm just scanning the entire table. But if we look at the query plan, we are doing this effectively in the most efficient way possible.
Very nice
from an engine perspective, right?
Very nice.
Good stuff. Yeah.
This is nice. This is really nice. I like it.
Yeah. And let me just I see we are kind of running out of time, but I just wanted to.
We always run out of time, and so that's normal.
Don't be too stressed.
Yeah.
I just wanted to show you this tree here because I think it's pretty impressive. So this represents the set of features and capabilities that we are grouping into this concept of intelligent query processing. Right, and intelligent query processing means that the query processor is taking intelligent decisions the moment it receives a query to parse, create the plan, and execute. And in dark blue here, you can see the new features that we are adding to 2022.
All right, cool.
Personally, I think what one of the most impactful one is going to be this. Parameter sensitive plan optimization, right? It's a pretty common problem for everybody, which is once in a lifetime has encountered that query that was running good for let's say 99% of the cases, but with one parameter value, the query was actually horrible. Responding in, right? Yeah. And the reason is that in the previous releases SQL Server was basically creating that query plan based on the first kind of parameterization of a particular query, looking at whatever predicate was sent, right? And that behind the scenes, of course, the query processing was looking at the data distribution through statistics and so on. But there were some corner cases where data distribution, for example, was not normal, or could actually create a version of that query plan that was not optimal.
Yeah.
What we are doing right now here is the query processor is actually creating a number of different I would say placeholders or stubs for that query based on a number of assumptions, looking at those stats in a more kind of advanced manner, right? So, and it's creating basically different buckets of parameters values, and is depending on essentially what effective parameters are going to be executed on that query execution, is replacing those tabs with actual query plans, right? But the interesting story here is that for a single query, you can actually have multiple versions of those query plans, right? So that depending on again the set of parameters that gets passed to the query at execution time, the engine will pick up the most optimized query plan for solving that particular query, right? And this is going to solve a lot of those corner cases and make sure that there are a few instances where a single query is basically running slower. And this is actually based on the query store. So it's integrated with all the other kind of intelligent query processing components, like all those feedback, query processing feedbacks for things like the degree of parallelism, right? Sometimes, the engine is just using all the processors because it can, but that using more processors is actually going to potentially impact others that are running on the same machine. Right, yeah. So this intelligent loop is checking and is basically adjusting the number of parallel threads that are used to execute a particular query in the most optimal way, while others are using other processors in the system, right? And the same happens for example, memory grant that gets allocated every time a query executes in order to accommodate the results, right? Sometimes. Depending on data distribution and such, the query processor cannot just guess the size of the result set that will come back, right? And there may be some misallocations in terms of more memory allocated or less memory allocated that can have effects on query execution times. This feedback mechanism is actually adjusting that memory grant so that the query will always receive the most optimal amount of memory, and will not, on one hand, will not spill on disks, for example, because the amount of memory was too low, or is not using an exaggerated amount of memory, basically eating memory to other query executions and so on. So those are all kind of optimized capabilities that we are introducing release after release, and making the query processing aspect more powerful in SQL Server.
Very cool.
We've certainly come a long ways since the days where you provide a SQL and there's one plan for it and it just executes, right? This still used to be my mental model up until recently of how databases actually work, right? You give a SQL, you get a plan, you execute the plan. This is very, very, very impressive.
Yeah, and if you search for that SQL 2022 workshop on GitHub, you will also find a great deck which is explaining in details all these different capabilities, and is matching that explanation with a full set of demos that you can use to reproduce all these optimizations.
Mm-hmm.
Well, yeah, wow. So this has been really good. Really appreciate you coming on, Silvano. There's been a lot of positive comments in the chat. People impressed by some of these things. Let me actually one question for you. So this is from Wraith2, who's one of our contributors for SQL Client. Is it likely, we've been doing support for JSON in EF Core and we haven't really needed anything specific out of SQL Client yet. Is that likely to change, with some of the new stuff that's happening?
Yeah, of course, there are a number of very interesting scenarios that are opening up with having this dedicated data type for JSON in SQL Server. In this very first release, we are not planning to add dedicated capabilities to the SQL client, but there are a number of use cases where we are actually investigating, a lot of potential integration between the client side and the server side. So, Red, stay tuned because we are going to work on this space, and maybe not necessarily just for SQL client.
Yes, so we may need you, Wraith. Okay, and just a couple of comments. Congratulations on the great work. Azure SQL's the best thing since sliced bread. So there you go. And and lots of other people there saying, great show. So yeah, really appreciate having you on. You had something, Shay?
Yeah, there's this question which Silvano already touched upon, but I just want to make sure people get this. So I happen to know even today, before the new support, you have some limited ways of querying using an index when querying into a JSON document, right? You create a computed column into the JSON document, and then you create an index over the computed column, and that allows you to optimize very specific query forms, like specifically for one property, querying inside the JSON document, so you can construct an index. But you mentioned that with the new support that's coming, one of the goals is to also open that up and make that better, more efficient.
Correct. That is correct. So we are. Again, the plan is to add native indexes with all the different shapes and forms that are also available on other kind of database providers, and that will be again fully integrated with the query processing aspect, right? So you just even from a predicate perspective, you don't need the kind of special functions in order to achieve index support, and not even those tricks that they work on very very specific scenarios, creating promoted columns or calculated columns.
Exactly,
it makes sense, but
it's not a scalable approach to the problem.
It's not super intuitive or friendly. We might be there as well, right? Having to create another computed column. So having it more first class is a lot. In
fact, what a lot of customers are doing today, they may want to store a raw JSON format within certain table columns, but during the insertion or updates and so on, they are taking those key attributes that they know they are searching for, and they are creating explicit relational columns, and
they denormalize the data out of the JSON, basically. Of course. Okay, awesome. Very cool.
Well, great stuff. So thanks Silvano again for being on. I'm sure we are gonna talk a lot in the coming weeks, months, years about making sure .NET works great with all of this stuff. I don't know. Do we know what we're doing next? Probably not, right?
I don't think so.
We never know what we're doing.
We do this from week to week at this point.
Yeah. But I know that Eric EJ wants to come on and talk about his cross-platform command line power tools. So that will be coming at some point. But I'm not committing him to 2 weeks from now yet. We'll just see how it goes.
Why not commit him? Eric, you're in the box.
Okay. Well, thanks everyone, and we'll see you again next time.
Thanks, folks. Thanks again for having me.
No problem. Bye.
Bye.
Bye, everyone.